All right, I thought I'd begin by spending just a couple of minutes talking about the environment in which we collectively operate. And when you look at the types of the things the government does, okay, it's generally grouped into three categories, which are traceable back to the preamble of the Constitution. Okay? Government is supposed to provide for the common defense, secure the general welfare, and preserve the blessings of liberty to ourselves and our posterity. Okay? In contemporary terminology, that's usually described as the defense budget for providing the common defense. The entitlements are largely tied to securing the general welfare. And the discretionary budget, of which NASA is a part, is the blessings of liberty. And I think that's where most of what we do resides. One could argue that earth science, particularly with the recent increase in emphasis in earth science in terms of a growing budget, is somewhat tied to securing the general welfare in terms of getting the scientific basis for improved policy making on climate change. But by and large, what NASA does, certainly things like planetary science, astrophysics, solar physics, are going to be in the blessings of liberty and in the discretionary budget. When you read articles about the federal budget, that's the area that is under the most pressure, okay? And it is something where you always hear about, well, freezes on the non-defense, non-entitlement pieces of the budget. So NASA operates in a very constrained environment. We're also an agency where our support tends to be very broad. I think most people like NASA. Most people think what we do is cool. But I don't think you can count a very large number of people who actually walk into the voting booth and cast their vote on the basis of what's happening at the NASA program. Okay. Within the Science Mission Directorate, the Earth Science budget has increased pretty dramatically over the last couple of years. But in our other three science themes, planetary, astrophysics, and heliophysics, the growth is modest, and in some cases it does not keep pace with inflation. Therefore, as we try to manage our portfolio every year, okay, growth has to be accommodated within the available budget. There's no, money just doesn't come raining out of the ceiling. And that's a rebalancing act that we are doing constantly. The other key feature of the environment is that there has been an incredible increase in interest on the part of our external benefactors, including the Office of Management and Budget and Congress, in cost and schedule management. It's no secret that we have had a lot of overruns over the last several years. And consequently, there have been several policies that have been put in place in an effort to get more visibility into that and to get it under control. Okay. In the Authorization Act of 2005, there was some language that established Nunn-McCurdy type controls on projects, which are basically a series of thresholds that are placed when we have to notify Congress. Okay, if we have 15% cost growth over the approved baseline, or a 6-month launch slip beyond the approved baseline, there is a fairly complex notification process where we have to let Congress know what's going on and the actions we are taking to mitigate the overruns. Should we exceed the baseline by 30%, it starts an 18-month timeline clicking, and when you get to that point, we need specific congressional approval to continue the project. So the default position is the project is canceled unless we get permission to continue. Of course, in some cases, if we launch within the 18 months, there's not really much they can do about it. But it nevertheless is an indication that there is just a lot of interest in this area. Okay, so in order to avoid cost and schedule overruns, it's important to establish the best baseline we can, and as some of the other speakers have indicated, that has really been an early pitfall in the resources control process. Okay, when we come up with estimates at the phase A-B transition and at confirmation, those estimates are usually based on parametric models, which are founded in cost estimating relationships that come out of historical data, complexity factors based on engineering judgment. Okay. When this is done, because so much of what we do in each mission is unique, there's plenty of opportunity for error. Okay? So how do we try to get this under control? And one major change in NASA policy that occurred a couple of years ago, which has been spoken about previously, but I'm going to go into just a little bit more detail on it, is the use of the joint's confidence level in establishing the baselines. Okay, this is done specifically in response to the external pressure. I thought Chris Scalise gave an excellent illustration of that when he spoke earlier in terms of speaking about reserves. How if you just say, well, I have reserve, that's an invitation to take my money. But if you say, but actually if you do that, it reduces the probability we're going to make it. It makes it a little bit harder to do that. And the other thing is, we want to be able to assert at a reasonable level of confidence that we have an executable plan in place. So by using a confidence level, we are saying very honestly, this is not certainty, it just represents a probabilistic analysis of our success, but we think we can do it at this level. Okay, these words, people are very good at cut and pasting out of policy documents, which I did myself to get this, and it's been said before, but JCL is the probability that the cost will be less than or equal to the targeted cost and the schedule will be less than or equal to the targeted schedule. It's a process that combines cost, schedule, technical risk into a complete picture, okay, and it helps inform management as to the likelihood of a project's success. Okay. Now, there are several things JCL is not, okay? It is not a specific methodology. There is no prescribed methodology in the policy documents. However, several JCLs have been conducted to date, and what we tend to hear about is the use of triangular probability distributions and Monte Carlo simulations. Now, basically what this is, without going into a lot of detail, okay, if you take, for example, estimating via a cost estimating relationship, okay, you can draw a simple graph of mass versus cost, okay, and there's a line with a slope, and out of that comes an estimating relationship. What JCL does, and the triangular probability distributions, is that as this review is conducted, what you may find is that estimators come around to you and your system managers, subsystem managers, and ask things like, okay, how long do you think it's going to take you to build this widget? Okay, and the answer is, let's just say, making up numbers here, 8 months. Okay. All right. What's the worst case scenario? Okay, could be 12 months. And what's the best case scenario? 6 months. Okay, what that does is it bounds a minimum and maximum. Okay, and you can construct out of that, very simple, by calculating the height of a triangle, okay, a triangular probability distribution for that system or subsystem. That's then done for the elements in the WBS. It's all integrated. Run it through a Monte Carlo simulation several thousand times, and out pops an answer, okay? While JCL is also not a product from a specific tool, okay, it is usually expressed in terms of a probability density curve, cumulative probability density curve, which is an S curve, okay, or in a scatter plot, okay? So we get some sense of having gone into this lower level of detail, looked at best case, worst case, and the median scenarios, what this probability is going to look like. Okay. If you look at the current policy on JCL, it's evident that it is very much a work in progress. The agency is a couple of years into this. We are still looking at it, refining it. There are additional details and examples at that website, and this is something that is then indicated. This is really not the proper forum for going into it and going in, showing a JCL, but it's something you very much need to be aware of early on because it's a process and a gate you're going to have to go through. Okay, so what are the actual numbers here? Okay. Each major program should be baselined and budgeted so that the JCL is at 70% probability of achieving the stated cost and schedule. Okay. At a minimum, projects are to be funded at a 50% confidence level. Okay, so that leads to really two key points about this. As a directorate, okay, it is on us, it is our responsibility to demonstrate how we budget at a 70% confidence level. Okay, however, the PI and project manager may be, and usually are given, okay, a budget and schedule control, budget and or schedule control below that level. Okay, there may also be a difference in the targeted launch date between what you are asked to being managed to and to what we commit to externally in order to demonstrate the confidence level. Okay, let me just focus in on one aspect of that. The 70% is set at the program level. Okay, and programs, although we have single project programs, programs are generally composed of of several projects. So in demonstrating it at the program level, okay, something we could do and often do is say, well, look, when we have a competed program that makes selections and has a future missions line for future selections, some of that 70% resides in our ability to use the future missions line should need be. However, that is very painful for us, and it is very painful for things that cause that, because I don't think anybody wants to be the cause of a delay in an AO for a subsequent opportunity. So this is the type of thing where it is as I said, it's a process and a gate that everyone's going to have to undergo, with the idea of getting a better confidence that we can actually deliver what we say. Okay, this is a list of some key cost and schedule risk factors that hopefully we drive these out through JCLs, but this is just something to be aware of as you develop the program plan. Early key technology developments. Some projects are more technology dependent, more technology intensive than others. Software development. This has been an area as we track project progress, has been something that often comes up as a problem area. Insufficient pace in terms of writing lines of code, going back, having software test failures, need to rework. Integration and test. When things start to come together, they don't always come together as well as originally planned. Denham certainly made a big point on this, and I think with complete accuracy, that the workforce is plotted out, you hit a peak in development, and there's an anticipated roll-off. It doesn't happen. Okay, the workforce tends to hang at the peak longer than anticipated and roll off more slowly than anticipated. And as everyone here knows, labor is the major cost driver. So when that happens, we are almost invariably looking at a cost overrun. So it's important to acknowledge that in developing the plan from the very outset. There are some externalities here, things that may be beyond our control in the launch vehicle world, dependencies on external partners, suppliers going out of business. Sometimes we have to make budget changes due to congressional earmarks and things like that. There are some things that you're simply not going to be able to control, but it's important just to understand what those are so you have an overall assessment of the risk. Okay, so how to reduce some of this risk that tends to be inherent in mission baselines. One is to heavily discount the benefits of heritage hardware. There are all kinds of aspects of what heritage hardware is, and you can say, well, look, this is identical to something that was built before, but is it really? Okay, it could be being built by the same company. Is it being built by the same team, following the same processes? Is it going to be used in the same environment? okay? All of these things tend to vary a little bit. So to say simply, well, you know, we're building this widget and we built that widget before, that's not always exactly the case. It's important to have ample unencumbered cost reserves and funded schedule reserves. The amount of reserve is something that has been debated endlessly, and I think will continue to debate endlessly. There is a canonical number out there of about 30% that many people feel comfortable with, and that I think is okay as a starting point, but I also think it's important to look at reserves and base reserves on the assessed risk rather than just a set of fixed rules. There may be some components that require more, some that require less. You know, those are the type of complexities that really need to be thought about. Certainly, D-scopes are important to have at different points in the life cycle, but I think as Denon so ably indicated with that very vivid graph that I think really bangs the point home, D-scopes can get you something at the beginning, but as you get into development, there really is not very much. And there may be still things you can do, throw an instrument overboard, but then that compromises level ones, and those things are not taken very lightly. So that's an important point, but also recognizing that it has to occur early. Okay, just a few additional thoughts on reducing cost and schedule risk. Yeah, NASA, its people, the people we work with have been known back to, you know, the Space Act of '58 for having a can-do mentality, and we have delivered on that, okay? And that's a strong asset. I mean, we certainly want people who think they can get the job done. But that also, when you follow that down the road a little bit, it sometimes leads into, well, you know, we can do, we will do, if everything goes right, we'll just make it. Everything won't go right. Okay, so it's something to be aware of. In planning out schedules, you know, we tend to think, you know, well, if you have schedule concurrency saves time, and time equals money, so that's a way to help keep costs down. But that really isn't true, okay, if you have a significant development problem in the critical path, or, you know, and when you have a problem when you're at that peak of the labor force. Okay, so you can try schedule concurrency, but it doesn't always translate into cost savings. In fact, it may produce a set of circumstances that helps produce cost growth. The final point, I was looking for a good way to capture this thought, and I was just searching through some quotes, and Sun Tzu said this better 2,500 years ago than I could phrase it. So what Sun Tzu said was, do not repeat the tactics which have gained you one victory, but let your methods be regulated by the infinite variety of circumstances. Yeah, an awful lot of everything we do is just explained by fundamental human nature. And I don't think there's anybody in here, you know, confronting some aspect of their professional life or personal life that's thought, well, I did it that way before and it worked, so I'm going to do it that way again. And that's a very natural tendency. But when we're dealing with cutting edge technology, first time things, one of a kind things, it also is the case that the circumstances have changed a lot, and it's something I think we need to acknowledge in our planning. Okay, establishing the baseline, establishing a confidence level around the baseline are all things that are done at key points in the project, key decision points, or should a rebaselining be necessary. But another important aspect of program project control is monitoring how we're using our resources, okay? More of a month-to-month assessment on how things are going, okay? And one of the things that has developed in the agency over the last several years is that the use of earned value management is now required on all NASA projects that have that are greater than 22 million life cycle, KDPC to KDPE, okay, and that's per 7120. Okay, what is EVM? It's an integrated management control system for quantifying, assessing, and understanding what is being achieved with the financial resources. It integrates cost, schedule, and technical risk. It allows an objective and quantified measure of current project performance, and it helps predict the future based on current trends. Having looked at a lot of EVM data, I think its greatest use is an early warning system for emergency problems. It does not provide the answers, but it's a good agenda setter for the questions. When you see EVM data trending in the wrong direction, it's time to start asking what's going on. Okay. There is a lot of information out there on EVM. If you just Google it, there are tons of canned training packages and all sorts of presentations available. And it quickly turns into an alphabet soup when you look at this, and many of the acronyms are similar and are easily confused. Every time I look at EVM data, I sort of keep a key handy because it's tough to remember this. But it's all based on three major elements, okay, which I think are most clearly described as the plan, the investment, and earned value. Okay, the plan is often referred to as the budgeted cost of work scheduled, okay, which is how much you plan to spend by a certain point in time. Okay, so just a key and obvious example of that is you have a certain number of hours that you estimate are going to complete a certain task. You have an average hourly rate. You do that simple calculation, and that's how much you have budgeted for the work you have scheduled in that period. Okay. The second key element is the investment, okay, which is what it actually cost you, okay, or how much was actually spent by a certain point in time, okay? So to complete a certain task, you estimated a certain number of hours at a certain rate, but in fact, let's say, first time ever, it takes more to do that. So what you've actually spent is the rate times the number of hours it actually took. Okay, and then finally, the earned value is the budgeted cost of work performed, okay, or how much of the planned work has actually completed, okay? So that is the cost you originally budgeted to accomplish the work you finished, okay? That's how much value you have earned, okay? Using those basic measures, there are two fundamental variances we look at: the cost variance and the schedule variance, which are simple subtractions, and they're set in the direction so that the negative is bad for both of those. Okay. Also falling out of those three basic measures are two basic performance indices, which are the cost performance index and the schedule performance index. Now, there are also, if you look in some EVA-specific training material, there are many additional metrics that fall out of those basic measures, but these are the key ones. What I thought might be worth focusing on, rather than looking at a bunch of calculations, is just to look at a few key things that are characteristic of this process. Okay? There is one escapable truth in EVM. If we're actually going to launch what we build on some schedule, the SPI eventually is going to equal 1. You have to get there. You cannot continue to underperform schedule and make it. At some point, that SPI must come back up the curve. How does that happen? Well, reserves are expended to buy back the SPI. And a very simple analytic technique is to take a look at the rate of reserve depletion over time, and that basically tells you whether the project is going to get there or not. Okay? If reserves are being expended and that SPI is not improving or not improving significantly enough that it's going to get to 1 at launch, it is an indication of a very serious problem where, generally speaking at that point, optimism is all over. Okay, something is going to have to be done in order to make that work. In addition to that, what I call an inescapable EVM truth, there is also an inescapable EVM limitation. It does not assess the quality of the project or the product. So you could be building something, you could be building an instrument, the SPI could look great, the CPI could look great, and if it fails on the test stand, that wasn't something that earned value was going to tell you about. So even when trends are looking good, it can't be separated from technical performance. That still has to be factored in all the time. Okay, there is a good tutorial on one of the NASA sites, but this is also a sufficiently mature field. EVM has been around a long time. It became a NASA requirement fairly recently, but it's been in practice for decades. There is, so you can look at that site, but if you just Google it, there's lots of really good detailed material on EVM. Okay, that's not the only thing we use. It's a requirement, but we also look at several other measures. We look at reserves on cost and schedule to go. We do simple cost burn rate calculations, how workforce is being utilized. As I said, labor is a huge driver, and what's going on with the workforce is often a very, very good predictor of what's going to happen to overall cost. How many key milestones are getting accomplished, what the status is of liens against reserves, and many others. This is stuff that we assess at least on a monthly basis. We have a review system that comes up from the centers through headquarters. Our deputy AA for programs, Mike Luther, runs a monthly flight program review where looks at technical progress and cost and schedule data, and that flows up into an SMD monthly. Understanding all of this is well and good, but it is meaningless unless it is followed by prompt management action. And as we've seen on so many projects, the data become inescapable fairly quickly. And when trends start to go badly, it's something that requires the earlier the action is taken, the better the probability of a successful result. Okay, so in sum, successful project resources control, it's an ongoing process. It requires continual management attention. It's a well-informed balance between implementing cost control measures while at the same time identifying management risk. Fundamentally, I think project management is all about risk management. And I'll let that last quote from an anonymous source speak to itself.